that involves both law of cosines and law of sines. Okay, so we have a ship leaves port A and travels 74 kilometers due west to buoy C. Then it adjusts its course 70 degrees north. It travels 125 kilometers in that direction until it reaches port B. What angle theta with respect to due west could the ship have used to travel directly from port A to B? And what's nice is we've got this nice diagram that kind of maps that all out for us. So really what we're charged with, that the question that's being asked is to find this angle. We don't have a right triangle, so we're going to have to use law of sines and law of cosines, depending on what we have here. Okay, so we have a side. We can easily figure out what this angle is because it's the two angles together, the 70-degree angle here and angle C, form a straight line, which is 180 degrees. So since I know that this piece is 70 degrees, then I know that this piece must be 110 degrees because together they must make 180. So I have angle C, and then I have the lengths of the sides on either side. So I can use law of cosines, to find side C here. So we'll use c squared is equal to a squared plus b squared minus 2ab cosine c. Okay, so c squared will be equal to 125 squared plus 74 squared minus 2 times 125 times 74, and then cosine c, so which is 110. Okay, so you'll use the calculator there in Alex to help you work this down. So just to save a little bit of time, so when you look make sure your calculator's in degree mode, but cosine of 110 is going to be about negative 0.34202. So c squared will be, I didn't write that down. So c squared is going to give you a number once you plug all of that in. And then to get c, of course, we're going to take the square root of that, which will be 165.6151. So you make sure you take it out a number of places so we only have to, we can round at the end. All right, so that gives me this side. So now I have enough information to set up law of sines. So we want to find angle A. So I can say sine of angle A, or theta, whatever you want to call it, over opposite that is 125, is equal to, and then I have, sine of C over side C. So sine of 110 degrees over 165.6151. Okay, so really you can think of cross multiplying here. You can think of multiplying both sides by 125 to get sine A by itself. So basically sine A is going to be equal to 125 times sine of 110 degrees all over 165.6151. And then since we really want angle A is going to be equal to sine inverse of that quotient, right? So that's what I'm going to plug into the calculator, sine inverse, and then of that 125 times sine 110 over 165.6151. And that will give me 45.2 rounded to the nearest tenth. So what you do want to keep in mind, since we're using law of sines, is that you could consider this, or remember, sine is also positive in the second quadrant. So you could also think of this angle, which would be, 180 degrees minus 45.2 degrees. So this angle, again, would be obtuse. And in this triangle, we already have an obtuse angle of 110. So it has to be that quadrant 1 angle, which is 45.2 degrees.